today we're going to talk about compound probability. We're going to review how to multiply fractions first. You're going to do your numerator times your numerator, denominator times your denominator. So basically 1 times 1 is 1, 3 times 4 is 12. Then you're going to see if you can simplify. This is in simple terms because I can't divide it any further. It is in the simplest terms. All right, go ahead and fill in the blanks, and then we're going to talk about these, what they mean. So compound probability is when you're talking about more than one thing, so 2 or more events. Independent is when one event does not change the outcome of another one. Some keywords you're going to be looking for is without replacing, with replacing, putting it back, or replacing it. For example, I have a bag of candies. I take one candy out, I look at it, and I put it back in the bag. So it does not change the outcome of a different event because I still have the same amount of candy in the bag. I just looked at it and put it back in. Dependent, it means that one event does affect the other outcome. So if we go back to the bag of candy, I grab a piece of candy, I eat it. Now I have a different amount of candy in the bag, so it will affect the second outcome. So now let's look at some examples and label them if they're going to be dependent or independent. So I'm drawing a Queen of Hearts from a deck. You're going to keep it, then draw a Joker. So because I'm keeping it, it is going to affect the other. So this is going to be a dependent event. Number 2, replacing a white sock from a box. I'm going to replace it. So I'm going to grab the sock, put it back in for a black sock. So this one is independent because I did get it out, but I put it back in the bag. So it doesn't change the number of items in the bag. 3, pulling a white sock from a box, not replacing it. Then back on the sock. So I'm going to let you figure out if it's going to be dependent or independent. Go to the next question in the back when you're done. Okay, so for this one, Haley is spinning 2 spinners as shown. Okay, and then this means that there's going to be 2 events. So the number of the events is going to be 2 events. And that means we're going to need 2 fractions. So I'm going to do 1 fraction and then another fraction. Because there are 2 events happening in the word and, that's going to represent multiplication. So I'm going to go ahead and set that up here. All right, so we're talking about what is the probability that she will spin a B on the first spinner and a 3 on the second. So those are your 2 events. There's 2 things happening. So for the first one, I'm going to write probability of getting a B out of my total. Okay, so what are my total options here is 4. How many of those are B's is 1/4. So I'm going to put that at the top. Now for the second event, so this is what I need. For my second event is the probability of landing on a 3 out of my total options. Well, this spinner has 3 options, so my total will be 3. Sorry, that should be total. Okay, so how many 3s do I have on this spinner? I have 1 3, and then how many total options? I have 3 options. So 1/3. So once I have my 2 events, all I'm going to do is multiply across. So 1 times 1 is 1. 4 times 3 is 12. So the possibility of these 2 events happening is going to be 1 out of 12. So my answer for this part is going to be 1 out of 12. Okay, let's do another one together. Let's do option B. What is the probability that she will spin a Y on the first spinner? And then, so the and means to multiply a 5 on the second spinner. So that means that you need 2 fractions for one event, for the second event, and then that's going to give you your answer. So for the first event, I want the probability of getting a letter Y out of my total. So how many Y's are here? There are 2 Y's out of the 4. So I'm going to go ahead and simplify because I know I can divide both numbers by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So that's my first event. So I'm going to transfer it over here. My second event is the possibility of landing on a 5. So I'm going to write the probability of landing on a 5 over my total. So they're talking about that second spinner. So what are my total options? There are 3 total options. How many of those are the number 5? Just 1. So this is already in simple terms, so I don't have to do nothing to it. So I'm just going to carry it on the little events. Okay, all I have to do is multiply top times top, bottom times bottom. 1 times 1 is 1. 2 times 3 is 6. And it's in simple terms, so I am done. Okay, last one. What is the probability of landing, spinning on an R on the first spinner and spinning on a 1 on the second spinner? So those are your 2 events. So that means I'm going to need 2 fractions. Okay, and I'm going to go ahead and set it up here. Possibility of getting an R over my total. So again, this first spinner has 4 total options, and there's only 1 R. So this right here is my first event. My second event is landing on the 1. So probability of landing on a 1 out of your total. This spinner has a total of 3 options, and there's only 1 number 1 on this spinner. So that's my second event. So I have 2 events. All right, go ahead and solve and block your answer on your paper. Okay, now I'm going to go ahead and do the next 2 examples with you because these are a little bit different, and this is when you'll see independent and dependent events. So example 2, Hillary has a box of colored eggs. Okay, these are all the eggs that are in the box. What is the probability that Hillary will randomly select a red egg, and then she's going to put it back, and then she's going to select a white egg? So there's 2 events because she's drawing 2 different eggs. So I'm going to go ahead and set that up here. I'm going to put my 2 fractions because I have 2 events. First thing you have to do is find out your total number of eggs that are in the bag. 6 plus 3 plus 1 is going to give me a total of 10 eggs. Okay, so the probability of me getting a red egg out of my total. So again, there are 10 eggs, and how many of those are red? 3. 3 out of 10. So this is in simple terms, so that's my first event. So I'm going to write 3 out of 10. The second event is getting a white egg. So she grabbed one, she put it back in the bag, and she still has a total of 10 eggs. But this time we want it to be a white egg. Okay, so how many white eggs do we have in the bag? 1 out of the 10. That's a simple terms. So that's my second event. Top times top, bottom times bottom. So 3 times 1 is 3. 10 times 10 is 100. So the possibility of this happening is going to be 3 out of 100. Now, this is independent because nothing changed. There was no change. She grabbed an egg and she put it back in the bag. Now let's look at the next example. It's a little bit different. Okay, now they want to know what is the probably getting a red egg, but this time she's gonna keep it. She's gonna eat it, throw it away, or do something to it. She's not putting it back in the bag or in the box. And then they want you to get a white egg. So this one's gonna be dependent. That means something's gonna change. Okay. There's still 2 events, so you still need 2 fractions. Okay, the probability of getting a red egg over your total for the first event. So let's find our total number of eggs. When you add 6 plus 3 plus 1, that's still 10 eggs. That's your total. Okay, so that goes at the bottom. How many red eggs do I have? I have 3, so 3 out of 10. That's my first event. Okay, the second event changes because she grabbed the red egg and she put it away. So now your total is not 10. I took 1 out and didn't replace it. So how many total eggs do I have? 9. All right, so this time they're asking the probability of a white egg. So how many white eggs do I have? 1 out of 9, that's my second event. So I'm gonna write it here. You're gonna do the same thing. 3 times 1 is 3. 10 times 9 is 90. Now this is not in simple terms, but I know that I can divide both by 3 to simplify it. 3 divided by 3 is 1, and 90 divided by 3 is going to be 30. So 1 out of 30 will be my answer.